So, hello everyone. I'm that guy over there. I'm from Prezi, and I'm gonna tell you a story about how we went from 0 users to 20 plus million users while scaling our infrastructure. So first thing you need to know, I have zero background in operations. I'm not really good at any of it. It's not my core competency. Yet I managed to make my way into the infrastructure team inside Prezi for some weird reason. And now I'm here to talk about how we managed to pull off scaling the whole thing. So some brief history. This is our user growth. This is actually our active user growth. And as you can see, there's some seasonality over there. So there are big drops and ups and highs. Usually the big drops are Christmas and the summer periods. And this is basically the graph of our outage minutes per month. So this, you can see that this correlates really well with the peaks in the user growth graph. And you can wonder why, but I'll leave that to homework. So basically, what's really important about these two peaks in the outage minutes is that these were like very, very small mistakes, like caused huge outages. So if you take them away, the graph actually looks pretty good, but I won't delude you, so here it is. So where did we begin? We began with only developers in the company, no operations people at all. So, what's so funny? So no operations people at all, only people developing the UI that you see currently. Actually, operations were outsourced to an outside company. That, creates a tension between operations and developers. Developers developing the code, operations trying to keep it alive, and sometimes it doesn't work that well. So we tried to hire an ops guy to bridge the gap. What he did was basically, he created copy-pastable instructions for setting up a machine so that we can migrate to Amazon, which basically provides us virtual machines for running all of our servers. So these were just, text files. You can copy and paste them whenever you create a new instance and then start. Also, since this guy obviously had a background in operations, he heard about configuration management. He actually used Puppet before, but he wanted to try something new. So he wanted to give Chef a try. Chef is like another configuration management system. You don't necessarily need to know anything about it. Okay, so this basically was his weekend project. So he migrated all these copy-pastable instructions over to Chef Solo, whatever that is. So eventually, he figured out that, okay, this is very good, so why not migrate everything to Chef? So he started working on that iteratively, basically one machine at a time. So he could do this by himself. So this was still a one-man show, one operations guy running the whole show, plus the outsourced company, but we don't talk about it. So eventually some magic happened, and now here we are today. We have over 50 contributors to the infrastructure, to Prezi's infrastructure, out of 60 engineers. We use GitHub, and this is what our commit graphs like. So you can see it's a pretty, you can see exponential growth there, but I'm not going to prove it today. So here we are today. We have lots of different teams. Every team has to be self-sufficient. Every team can modify Prezi's infrastructure. And we have one team called the core services team here, which I'm part of. But we'd like to think that nothing really special happens here. So we're just one of the teams. Yeah. So what was that magic bit there? Because I think that's really key. So there are three very big things. One is you should be able to jumpstart infrastructure very, very easily. So if you're a new developer, you have never experienced operations before, you should be able to jumpstart your infrastructure. Also, you should be able to share and discover knowledge. How do people usually operate Apache servers and stuff like that? Because I don't know. I've never done that before. And also, if you're one of those veteran guys, those experienced guys, you want to be able to customize and refine our configurations to your liking, because you know how to run those servers. So these are 3 very important things if you want to achieve 20 plus million users. Okay, so quick show of hands. Who knows what Chef is? Awesome. That means that I'll get to skip this whole part over here. So we have, Chef has cookbooks. A cookbook has metadata and some other stuff. And then you can have more cookbooks and attributes. And then you can group them to roles. And then you can have multiple roles. And then you have some other attributes. And then you can group them to nodes, which we call named and snowflake nodes, because these are the usual stuff that you upload to Chef. So this is basically a definition of a machine. But we have other stuff, exactly the same, called node, a throwaway node. So what's a throwaway node? A throwaway node is just basically a descriptor file in the repository saying, okay, this is how to build the machine. These are never uploaded to the Chef server, and they're basically just, you fire and forget them. You don't even know they exist. So these are just templates to start new nodes. So we have all that. We have, environments in the Chef. You can pin cookbooks to particular versions and stuff like that. You can have more attributes here, blah, blah, blah. Not interesting, boring, boring. You can have data bags, which are really just global shared data. You can store secret stuff there in encrypted form. And you can write your own custom knife plugins. Usually these are to just automate your tasks and make your life easier, but usually are written by frustrated people. Oh, I have to type this again. Oh, why doesn't this work? So the code is usually horrible. So okay, we have pulled in some cookbooks that were not written by us. These are called usually community cookbooks. We tend not to like them before. They were just a source of inspiration for us. But recently we discovered that they're very useful. Why didn't we like them? They usually are too complex for the beginner to understand, and they don't exactly do what we want. There's always something different or completely different. So there's 2 recipes here. You won't be able to read them, but that's not the point. The right-hand side is our version of setting up a package, and the left-hand side is a community one. So if you're a beginner, which one would you like to work with? Yeah, right. Yeah, sure. So it's confusing for beginners, right? Also, we're on this Food Critic, which is a static code analysis tool for Chef, with very strict settings, and usually community cookbook writers don't. But there are some nice examples on the other hand. So we managed to basically give them a try, run our Food Critic settings with basically per cookbook configurable strictness, and some other stuff that's not important right now. So, okay. So you've seen our Chef repo. That's mostly how it looks like. The details don't really matter at this point. So what you need to do in order to achieve that 20 plus million is to define a workflow for everyone that commits to the Chef repository, which basically is the code as your infrastructure. So here's our workflow. That's the secret sauce. You can read it. I'll give you a minute. Sorry about the font. So if you haven't finished, I'll walk you through. You start hacking on your favorite cookbook, and there's this, unless I bumped already. So basically what you need to do is, if you've never done this before, then you just run those 2 commands in red, nice pork bump, blah, 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 nice pork upload, blah, blah, blah. And what it does is it bumps the version inside a cookbook, so you have a version for every cookbook, and it bumps your cookbook version and uploads it and freezes it on the server. So the next time somebody tries to upload the same version, they will get denied because you already uploaded it. So yeah, you just upload it, and if you're not satisfied, then you repeat the whole process, but the next time you don't nice pork bump, but you just do knife cookbook upload, which won't bump your version again, and it will just overwrite it. So where's the magic? There's no magic here. What if this fails? If this fails, then there's probably somebody else working on the same cookbook. So you need to find him and fight. decide who is the more important guy. On the other hand, if it doesn't fail, then you have a lock on this cookbook, meaning only you can upload it. So you have to work fast, otherwise somebody will find you. So basically, that's just the magic. There's nothing magic. Right? Okay. So you have your workflow, but imagine 50+ engineers working on the same infrastructure with well-defined workflow. Something is missing, isn't it? Yeah. Testing. So 50+ engineers, especially if there are a couple of unexperienced ones, will fuck up something. There's no way it will work, right? Something will break. So you need to have more and more people, more and more bugs. And we have no staging environment. We have no dedicated staging environment because it was frankly hard to maintain. We didn't see any point in it. It works without it. So with these two given facts, it's very, very important to catch bugs early on. So you need to have proper testing, right? So what do you do to test your infrastructure? Well, we do 4 things. I've already mentioned Food Critic. This is basically just a static code analysis that runs through your code, like any other. They run automatically on each commit, as you would expect, or if you're not sure whether your code will actually pass, then you will run it manually before commit. We run them with very, very strict settings. Think like wall, where, pedantic for GCC. And there are also a couple of weird rules inside Food Critic which we don't agree on, so we just ignore them. We don't actually know how others do it, so we're very interested in input because we like Food Critic. Well, we actually like static code analysis tools, not Food Critic, but whatever. So the next thing we do is called Chef Spec, which is really just unit test for your cookbooks. They're supposed to be quick and easy to write and run. Sometimes they are, sometimes they aren't. And they're supposed to run automatically on each commit, obviously. They're not for checking system state. So they're not for verifying that your config file is really there. They're not for verifying that the service is running on your correct port or whatever. What they are for, however, is validating your custom Ruby logic. For example, if you have like custom logic for generating a file name that you will eventually use as your config file, then you can validate the custom logic that basically validates your sanity. So the third thing we do is called Minitest, which is a complete opposite of Chef Spec. They are useful for integration tests, post-converge for any Chef users there. It answers questions like, is the service really listening on the port it's supposed to be? So complete opposite of Chef Spec. On the other hand, it needs to start a virtual machine, run Chef on it, and then check the tests. So it's very resource intensive and time intensive. So you cannot really run all of them on each commit. So you need to be smart there, but eventually that's the goal. Also, we use Chef Solo with Minitest, which for any Chef nerds out there, search doesn't work with Chef Solo, so all of our code that uses search is practically untested. So the fourth thing you can do is run your cookbooks in a Vagrant box, which is basically just a virtual machine running your code and poking and prodding manually. Whether does it work? Does it work yet? No. Iterate. Does it work? So you can also use Chef Spec and Minitest with Vagrant, so you can check what the automatic test will do for you. And the manual cookbook testing I just mentioned. It dramatically shortens development cycle. So if you have like your cookbook and you're used to uploading it and testing if it still works and then uploading it again, that takes kind of a long time. With Vagrant, the breeze. So that's what we do for testing. Okay, so far we have 2 things. We have workflow, we have testing. So basically, we've ensured that new users are going to be able to contribute to our Chef repository, and they're not going to break anything because we have testing. So we have one more thing that's really important is if you've got those users, you got to retain them. which is where extending comes in. You need to be able to extend your Chef or your infrastructure to suit advanced uses, like those ops guys somewhere around here, I don't know. So we have 3 things, just very quickly breeze through them. One is called Knife File Edit, which is basically just a hack on top of Knife File, which is already a Chef plugin, which lets you handle encrypted stuff in JSON format. So what we did is basically we just wrapped, you open up your editor with a decrypted JSON file. That's what Knife File Edit does for you. So you call Knife File Edit blah, blah, blah. It opens up your editor with the unencrypted, so decrypted data. Then you edit it, and then you close your editor, and then it encrypts it and writes to a file. Oh, so awesome. And then you can upload it with the usual tools. So that's one thing. The other thing is much more interesting, called Knife EC2 server from file, which is a hack on top of Knife EC2, which is already existing Chef plugin. What it does is basically, so when you run Knife EC2, I don't know how many of you have, but you usually have command lines that are very long, very, very long. So you need to give the availability zone, what kind of image do you want to run, what kind of run list do you want to have, what kind of environment do you want, blah, 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 blah. And it just gets tedious after a while. So what you do is you put all of that stuff into a JSON file, save that to the Chef repository, and then have a command read that JSON file up and put those arguments to the normal commands. And that's what Knife EC2 server for file does. And what's very good about this is that, so you put this in the repo, and then others can use it. So you can create exactly same looking, identical machines, even though you're not the person who created the JSON file. And that's a very powerful thing to do. It's like manufacturing. And this is where throwaway nodes come in. So this is what I referenced back earlier. Throwaway nodes are just really templates for starting up new instances. And this plugin implements that. So are you bored yet? No? Who's bored? Great. So we have this third project, extending the Chef, which is really a huge project. It's for monitoring. Because, monitoring sucks. Like, sucks really bad. Yeah. So basically what we did was, so if you want to implement a monitoring solution, you have basically 2 choices. Either you go the old school way, using Nagios and stuff, which is really hard to maintain, and it doesn't really scale well to 300 plus nodes. You just have to edit your configuration files manually. Even if you use some kind of a Chef thing, a configuration management tool, it's just tedious. Or you go the new school way, which is, Sensu and all these fancy stuff, which is designed for the cloud and eats the cloud and, I don't know, breathes the cloud. But unfortunately, we don't have any experience with them, and we want something fast, because, when you want to implement your own monitoring system, you're usually in dipshit. So we built something in between. How exciting. What we did was basically an iceberg. Yes, this is an iceberg. We have the user interface on top, which is basically consisting of 3 separate components. The third one is optional, but 3. One is a declaration, which goes into your Chef recipe. So you say, I want to monitor the free memory, and you create a Ruby block, DSL. Wow. So you give a script template, script codebook, script arguments, and some alerts. So what are these script thingies? You can basically, what you can do is write a shell script or any kind of script, and the only interface it needs to adhere to is it has to output an integer to standard output. I think most of us can manage that. So yeah, that's my magic variable holding the free memory in bytes. So you write this script, put it in sorry? Was there a question? No? Are you sure? Yeah, really? Oh, shit. I think we need to fix our monitoring. So you write that script, you put it inside a cookbook, and you reference that from here. And what this will do is basically just schedule a cron job that will run your, or not really a cron job, but whatever. It schedules some kind of a job that will eventually call your script periodically and check its output and compare it to against the alerts that you specify there. So this says that if the output of the meminfo script is below 128,000, then issue a warning severity alert. Simple. Like, so what's really important about this is if you've never seen this, you probably understand what's going on. That's very important. So you can do one more thing with this. If you really want to get woken up, you can say like where to wake me up. You can choose between PagerDuty, which is a startup for notifying people and waking them up. You can receive alerts via HipChat or email. Simple. Just put them inside a data bag and reference them from the Ruby block. So one thing that's very striking about this, it's fucking simple. You understand what's happening, right? Who doesn't understand? Come on, right? So that's the user interface. That's what every beginner needs to know. But there's a couple of other things inside the internals, which are really three major components. Who is interested? Fuck, I have to talk. So on the left-hand side, you have the Ruby client, which basically just implements the LWRP, which is the DSL you see in above. It implements it with the Chef stuff, and then it communicates with some kind of an API. It's Ruby code. So we have this REST API, which is really just it's just a data model and an HTTP API in front of it. So it's a relational database. You can have checks on the bottom for every node, and every node connects to a broker, which then checks the checks for every node. Easy. So yeah, you have this REST API, and then oh, I'm so sorry. Yes. So let's go back. This is implemented in Haskell. Thank you, but the applause doesn't go to me. Where's Abesto? Yes. Wait. Yeah, okay, so the question was, what was the question?
Sorry, what language is this API implemented in?
Ah, yes, so it's in Haskell. And the guy who implemented it sits over there. Stand up. Hello, Abesto. Cool. We got that behind of us. So there's another thing called the backend, which pulls the same HTTPI. It basically just gets a snapshot of the current state of monitoring and generates a configuration for Isinga. Isinga is basically just Nagios with a different name. It's a fork. So what Isinga does for us is you basically keeps track of our alerts, sends emails, sends them to PagerDuty, sends them to HipChat, all that stuff you've seen on the top. Plus, a really nice thing is it tracks every single output of the shell script in Graphite. So you have nice graphs of everything in your infrastructure. That's really nice if you have the storage. So that's it. Very cool. So now we can extend, we can test, we can create workflow. Everything is happy, everybody's happy. So you've come to a point where if you've implemented all of this, it's very hard to fuck up from here on. The only thing that you need, from our perspective, what we did was basically create a concept of ownership, which is kind of weird because you hear ownership all over the place, but we mean a very specific kind of ownership here. Basically, you have a service, and it's owned by a single team. So, I don't know, you have your meeting servers, then you have a meeting team which owns the meeting servers. What's the good about this? Oh, and nobody else owns the meeting servers. So if the meeting servers go down, guess who gets woken up? The meeting team. That's good for us, because it's not the infrastructure team. So ownership gives you, space to implement your own stuff, because you will get woken up, and you are responsible for making that service better. So eventually some general purpose cookbooks arise, and then they get shared across teams, because they're usually good quality. The other thing that we do is training. If you come to Prezi, we have a 2-week boot camp that you have to go through, which is basically just, you go to each of our teams and see how they work every day. And you spend, I think 1 day with every team. And so you'll get a whole picture of how Prezi works internally. So you get a feel for the diversity. There are very different, from the infrastructure perspective, there are very different quality measures for cookbooks across teams. But yeah, that's for the training part. And the third very important thing is review. So if you're responsible for a service and somebody else commits to code in your service, you obviously have to code review it. That stands for infrastructure too. It's not special, it's just code. We also have brown bags that are basically just telling other people how we work and then sharing, ideas and stuff. So you can review how other people did what you might have not been already thinking. Yes. Yeah, so you can go to brown bags and steal ideas. And also practices. We sometimes, if it's a really hard problem, then you just shoot out an email, and if somebody's already done it, then they'll answer. So all this leads to one very important thing. The land of rainbows and unicorns. So the main message here is we don't actually have a dedicated operations team. We have a team called infrastructure, but they're not really special. They're just running a bunch of services. That's the magic sauce. So to reiterate, 3 things. You have to be able to jumpstart infrastructure very easily for beginners. You have to be able to share and discover knowledge for beginners and experts alike. And you have to be able to customize and refine your infrastructure for experts. Yeah, questions? Okay, then thank you.